Okay, in this video I'm going to be going through another example of how you can use stoichiometry to work out the mass of something given another mass. And in this case, what we're trying to work out is the mass of a reactant given the mass of the product produced. So we're going to use molar ratios and the periodic table to work this out. Okay, so in the question says nitrogen gas can react with hydrogen gas to give ammonia, which is represented by NH3. Calculate the mass of hydrogen needed to produce 6.8 grams of ammonia. Okay, so the first thing which I'm going to do is create a balanced equation. And I'm going to create a balanced equation involving N2H2NH3. So nitrogen gas, which is N2. Let me do this in green, since N2 plus H2 produces NH3. Let me do that in purple. NH3. And so now we need to balance this equation. So in order to balance this equation, I'm going to look at the amount of nitrogen. So for nitrogens on this side, we've got 2. For hydrogens, we've got 2. And for nitrogens on this side, I've got 1. And for hydrogens on this side, I've got 3. So the first thing I'm going to do is, okay, I see there's 1 nitrogen on this side and only 2 and 2 on this side, and there's only 1 here. So I'm going to multiply the right side by 2. So put a 2 here. And now we can say we have 2 nitrogens and 2 nitrogens. So the nitrogens are now balanced. And since I multiplied this whole molecule by 2, the whole NH3 molecule, the hydrogens get multiplied by 2 as well. So this changes from 3 to 6. And now, so we have 6 hydrogens on this side and only 2 hydrogens on that side. So now the hydrogens are unbalanced and we need to balance it. And we can balance that now by multiplying the hydrogens on this side by 3. And 3 times 6 will cause the amount of hydrogen on this side to be 6, because 3 times 2 is equal to 6. And so now we've got 2 nitrogens, 2 nitrogens, 6 hydrogens, 6 hydrogens. So now this equation is balanced. And now we can use that equation to solve the problem. So let us continue. So nitrogen gas can anyway, calculate the mass of hydrogen needed to produce 6.8 grams of ammonia. So we know that the mass of ammonia we have is 6.8 grams. And from the equation, number of moles equals mass, small m, divided by molar mass, big M, we can use this to work out the number of moles of ammonia we have here present in this reaction. So in order to work this out, we're going to need to work out the molar mass, big M, because we know the small m, which is the mass, but we don't know big M, which is the molar mass. And what we can do is use this periodic table here to work it out. So I'm going to do that now. And so let's do this in purple. Nitrogen. The relative atomic mass of nitrogen is 14, as you can see. So 14 plus, and we've got hydrogens, we've got 3 hydrogens here, so plus 3 times 1, because of the relative atomic mass of hydrogen is 1, and then we have this 2 here, but we don't need this 2 right now. All this 2 is for the molar ratio calculations, and right now we're not using the molar ratios. We're just working out the molar mass of what the molar mass of one molecule of ammonia, NH3, would be, and that would be 14 plus 3 times 1. And if I work that out, it's basically 14 plus 3, which is 17. So the molar mass of ammonia is 17. Mr equals 17 grams per mole. And so now we can use that 17 alongside this 6.8, And what we need to do is use this equation. So to work out the number of moles, we divide the mass, 6.8, we divide this by the molar mass, which is 17. So 6.8 divided by 17, which is equal to, let me use my calculator, 6.8 divided by, oops, so yeah, 6.8 divided by 17 equals 2/5, which is 0.4. So the answer to that would be 0.4 moles. There's 0.4 moles of NH3, right? And using that, knowing that there's 0.4 moles of NH3, we can now look at the molar ratios in this equation. And we're trying to find out the mass of hydrogen needed. Now, the ratio between nitrogen and hydrogen in this particular equation is a 3:2 ratio. As you can see, three hydrogen molecules for every one nitrogen molecule, for every two nitrogen molecules. So it's a 3:2 ratio. NH3. There you go. So it would be 0.4. It would be a ratio of 0.4 to 3/2 times 0.4, because in order to convert this to the other side, we would need to multiply that by 3/2. So if we do that, 0.4 times 3, well, 0.4 times 3/2, what we get is 3/5, and which is 0.6. So this is 0.6 to 0.4. So for every 0.6 moles of H2, we have 0.4 moles of NH3, which is what we have. So using the knowledge that we have 0.6 moles of H2, we can now work out the mass of H2. And so the way we do this is we use the equation, this equation, but we rearrange this equation so that we're solving it for the mass. And the way we can rearrange this is multiply both sides by the molar mass. So number of moles times molar mass would give us the actual mass. So the number of moles, 0.6, which is going to be N, multiplied by the molar mass. And this is the molar mass of hydrogen. And as I showed you before, the relative atomic mass of hydrogen is 1. So we're just going to multiply it by 2 times 1. No. We're just going to multiply it by 1. Because it's for hydrogen. We're using the ratios. We've already used ratios in the number of moles. So we multiply that by what? No, actually. We multiply it by 2. We multiply it by 2 because it's a molecule. It's a whole molecule of H2, which has a mass of 2, of molar mass of 2. So we multiply 0.6 by 2, and what we get is 1.2. Therefore, now we've got our answer for mass. This would be the mass, 1.2 grams. Therefore, we need 1.2 grams of hydrogen gas. Whoa, of hydrogen. 1.2 grams of hydrogen. And this is our answer. So yeah, that's it.